Okay, I think we're safe to go ahead and get started. So today we've got Anthony with us. He's going to be going over a project that he's been working on. I'll let him introduce himself a bit more fully than I can. But he is doing this presentation as a part of our ArangoDB Community Pioneers meetup. And actually, before I get ahead of myself, make sure we're recording. Okay. We are recording, and this Community Pioneers is open to anyone in the community working with ArangoDB that might have a cool project to show off. And this doesn't have to be in the form of a webinar. If you're interested in something like a blog post tutorial, use case, anything that you'd like to tell the ArangoDB community about your experience in working with ArangoDB. It doesn't need to be an app that you have in production or made for your company. It could just be a cool project that you made using ArangoDB. So if you have anything like this, please definitely reach out. And we're always happy to even just hear about it, even if you don't want to do a blog post. I personally am always interested in seeing how people are able to use ArangoDB. So other than that, I won't take up too much of the time. This will be Anthony's meetup. And if you have any questions throughout the meetup, please put them in the chat, the QA section. And again, if you'd like to ask it over audio, definitely feel free to say as much and we'll make it so. Other than that, I will hand that off to you, Anthony.
Cool. Thank you again, Chris Woodward. It's been a pleasure meeting with you, and thank you again for organizing this. So for those who want to know a bit more about me, I am a computer science student at the University of Ottawa. I just finished my third year there and entering my fourth year in fall. I've been doing internships in the summer over the past 3 years, mostly doing some DevOps and microservice development work. And on the side, I work on side projects that some have impacted some of the students at the university and others were just out of pure personal interest. This project being one of them. So I'm super excited to be presenting today. I'm gonna go ahead and start sharing my screen and then we can get started. So, okay, and I'll bring you guys over here. So feel free to cut me off anytime, if you can, if the voice chat is enabled, or just send a chat. I'll keep an eye out on it. Okay. So I'm going to start off by giving you guys the outline. We're going to be going over these little 6 points today. Hopefully it should last anywhere in between half an hour to 40 minutes, and then we'll leave some time at the end for Q&A. We're going to start off with giving you guys a bit of context as to what this project is. Then I'm going to go off and talk about a bit about the demo and the website itself. I'll switch over and talk about the Arango database structure that I've decided to make or to design for this project. Talk a bit about the architecture of PicsUm Vision, and then we'll finish off with the most important part. I'd argue is, how does ArangoDB play its part in this application? If we have time, we'll talk about the onboarding as well. But I would say that points number 3 and 5 are probably a bit on the heavy side, and then 1, 2, and 4 are a bit lighter to listen to. So again, cut me off anytime you guys want. So what is PicsUm Vision? It is, simply stated, a searchable image repository powered by a graph database. That is it. You can search for images, you can look for images similar to images you've previously clicked on, and you can visualize your results. So why did I decide to build this? Well, I've never experimented with graph databases for the first time. I've never had the chance to do it. So this is a first time, and I've heard good things about Arango. It was also part of my Shopify internship application for fall. Every developer intern applicant must go through a developer challenge. And for this specific term, Shopify said to build an image repository. They left it pretty much up to you as to what you want to do with it. They recommended, hey, why not trying inserting, deleting, selling, buying, or sharing images? I wanted to give a go on searching for images, and it makes the most sense to use a graph model database for this. So who's my target audience for this project? Well, it's for those who want an Arango getting started project. So I want to clarify, I am no expert in Arango. I've only have about a month worth of, just experience on the side after work hours or after school. And this is for someone who wants to take, a few hours out of their day just to figure out, okay, like how does AQL work, or how does any of these topics, how could any of these topics help me build, a cool graph database application? And so to give you guys context, back to the Shopify discussion, I found out about the application on April 30th of 2020, and the submission date was May 9th. So I had about 10 days to submit something. So what you see here today was there as of May 9th, right? All of it was there. And now what I've been doing in these past few weeks is, okay, I've got the base down. How can I optimize my queries? How can I clean up my code base? How can I improve the visualizer functionality? Stuff like that, right? So if you want to get started with Arango, this would be a cool project to mess around with. So we've gone over the basic questions. I'm going to start going into a bit like, a bit more detailed as to, where am I getting my logic, my data from? So my images are coming from Lorem Pixum Photos. So for those who don't know what that is, it is a image data set of about 990 images. And they range from a variety of sources, some being from Unsplash. And it comes with very minimal metadata. What I mean by this is, you can fetch about hundreds of images, but this is as much as you're working with, right? So you've got your ID, your author, and your URL. So which begs the question for me is, does this image source provide descriptive metadata? For me, I would say not really. It doesn't help me search. I can search by author, but that's about it, right? What if I want to search by dogs or by mountains, for example? So how do I generate my image metadata? Well, I do so from the Google Vision AI. For those who don't know what that is, it is a pre-trained machine learning model for image classification. This is just a fancy way of saying, I upload an image, Google Vision returns back some metadata that is associated to that image. So we're going to try that out. We're going to try it out right now, just to give you an idea of what this thing can do and how I'm using it to populate my metadata or get my metadata. So I've got two images that we're going to try. One I believe is from Norway, and this is from New York City. Two very contrasted, very different images. And the principle is kind of basic. So let's say if I upload the New York City image, I'm gonna expect some metadata results that I can use for my search functionality. So the first thing that it returns is, and this is crazy, a landmark association. So Google Vision is able to recognize that, hey, I am 54% sure that this is New York City. It is also able to detect objects, and from here it'll associate confidence scores to them to say, how sure am I that this image contains what I'm mentioning? And then there are also labels, which again, the same concept applies. And these can range from a variety of different words, nouns, adjectives, verbs, anything of that matter. We can also look at the dominant colors, which is one thing that we also use for this project. You can search by colors as well. So I'm gonna show you one more demo of it, just to give you an idea. We're still doing okay on time. And again, if anyone has any questions, Chris, I don't have access to the chat right now. I think it disappeared from my screen, so feel free to cut me off if somebody has one. So
no worries, I'll keep an eye on it.
Sounds good. So I'm gonna go ahead and upload this image, which is, I believe the place is called Pulpit Rock. It is in Norway. So we'll wait for that to finish. And again, I think this is in Norway. I could be wrong, but I won't even try to pronounce that. Google Vision is able to return, once again, a landmark associated to this image, along with some labels and some dominant colors. So if this should start making sense now. Okay, I'm using a graph database. I've got my images, I've got my metadata, and I can represent data relationships via the ranking that Google Vision assigns, right? So for this image, it is 98% sure that I see water, right? So I have two vertices, one being this image and one being the water, label, and I can assign a relationship of 98%. Suddenly, you can start getting an idea of, okay, this is how I'm building my graph. Okay, so enough about Google Vision. or the try me aspect of it. I do want to clarify, however, that Google Vision offers a few features, and we're using most of them during this project. Google Vision offers face detection, landmark detection, logo detection, label detection, and what we're using specifically, object localization. This is quite interesting. I'll come back to this, but you've seen an example for the New York City. This is just being able to detect specific objects within the image and even providing coordinates. So, you can wrap a specific object in a polygon and say, hey, I see a bicycle within these coordinates of this image. So I'll show you later on how we take advantage of this. Okay, so the obvious question, how do you structure your data? Well, your images and metadata are represented as vertices. Simple as that. If you're building a graph database, you want to have your vertices set as one, the thing you want to search for, and two, the documents that help you find your images. So their relationships are defined via ranked edges, just like with the percentage score that I mentioned earlier. And now suddenly your graph traversal is now accessible via the Arango query language. I'm going to quickly jump to AQL and talk to you very briefly about it. ArangoDB is considered a NoSQL database service, but they have their own query language called ArangoDB query language, and it's very English friendly. It's very readable. Your classic select query can be pretty easy to do. These are basically just a comparison if you're interested later on to look at what sort of syntax does AQL use. But again, we can come back to that later. Okay, so you've heard a bit about my project, or the context at least. I'm going to show you a demo. We've just passed the context phase. But what I'll do before that is I will share the link with you so that you are able to, if you feel like it, if you get bored listening to me, you can try it along. I just have to figure out how do I navigate this this message menu. Hang on. Okay, chat. Expand.
I got it. I'll paste it in there.
Oh, cool. Okay. I was thinking, there we go. Yeah. And that's perfect. All right. So instantly what you're seeing here is you're greeted by a landing page that quickly describes what ArangoDB, what Pixum Vision is, along with some database metrics. We'll come back to what exactly each keyword that you're seeing here is. We'll definitely come back to this. And I just want to check with you, Chris, is this too small? Is the font too small? Can you see right?
I think it's pretty good. It might zoom in just a little, but yeah, otherwise, I mean, not too bad though.
Let's do it. I'm at let's go 100. Okay.
Perfect.
So you're greeted by a navigation menu that goes through, your three basic pages. You've got your about page, which is kind of boring. We're going to skip over that. You've got your history page, which ties into your search page. So let's start with that. You're greeted with a simple and elegant search bar. I didn't want to go into advanced searching with multiple choice, radio buttons and checkboxes. I want it to be as simple as possible so that you could search for something and, you can get accurate results or somewhat accurate. And this ties back to, I'm still a student. I'm trying to figure this stuff out, but I have good progress with ArangoDB, and thankfully their documentation is easy to follow through. So let us search for something very simple like computer, and it's pretty quick. The indexing here is, or the beauty of ArangoDB is that I'm using Arango Search, which I'm going to talk about later, but this is why it's super quick, right? I'm combining Arango Search with graph traversals to find all the metadata that is associated to these images. So this is a basic example of what you could find. If I were to click on an image, I would be greeted with some information. Let's go top to bottom. So you've got your image, you've got your author right here, you've got your image URL, and then you've got your best guess. This is unique. We've never seen this before. So Google Vision, for every image, assigns a best guess to the image. And it's just a way of saying, if I had to describe this image in one sentence or in these few words, this is what I would say. So At times, Google Vision is very useful in the best guess context, but sometimes it's not that useful. So we'll check out some bad examples later on of what a best guess could be. You can expand this accordion to look at all the tags that are associated to this image. If I had to guess, there's probably about under 40 or maybe 50 tags at the maximum for this image. And then these last 6 images here are considered visually similar images that you might be interested in clicking on. And so this is sort of the endless treadmill that I kind of want to see if users would follow through with it. Just endlessly clicking on new images, discovering ones that they've never seen before. As you're clicking on this, what you're doing is you're traversing through the ArangoDB graph. You don't know, this is not stated to you, but that's exactly what you're doing. You're going from one node to another. And what I'll do now is I'll go back to the search menu. We still have our computer search. One thing that I wanted to implement, I probably spent a bit too much time on this. This is the visualizer feature. It has nothing to do with ArangoDB in the sense that we're using it for searching. Like, yes, we have a query to render the graph, but this is powered by Viz.js, which is a library for graph visualization. What I want to do here is I want to try to convince you that the images that showed up are there for a reason. They're there because we've matched all of these vertices, and we found that based on their rank and based on the number of times or the number of vertices they share, for example, this one, we believe that it is a accurate image to display for your respective query, right? So again, this is purely just out of interest for me. I wanted the user to try to understand, okay, you've searched for something, but why is that image specifically showing up? And then you look at, this image, for example, say, oh, that's why. Look, they've got like over 10 connections that all match, computer stuff. And to continue on with this quick demo, you can traverse the graph if you want. You can double click on a label, and suddenly you're back to the search menu with a different topic, the one you've clicked on. I can revisualize, and instead of clicking on a label, I can double click on an image, and then suddenly you're here. The same case applies for visually similar images. If you want to understand why are these top 6 images showing up when I click an image, well, that's because look how much metadata they have in common. They almost have all of them. This is a work in progress. Later on I will be displaying metrics and such, but the same traversal concept applies. You can double click, look at different images. So while I'm presenting, feel free to try different stuff on your own. The surprise me is a feature that just searches with a random input. And if you don't know what to search for, and your history page is just a place to track what you've clicked on, what you've searched. If you want to play back, a specific search, it's already cached, so you're not making another query. And you can also favorite images if you'd like, but that's kind of a dead feature right now. I have to find a way to take advantage of it. So that's about it. What I'll do is I'll switch back, but I will be referencing this website a lot more when we get to the query side of things. So we've just passed the context. We've just passed the demo. Now we're going to talk about the database structure. Why did I decide to structure my database this way? And things like that. So what you're looking at here is an example of 2 images, the nodes in black, image 428 and image 331. It's a bit hard to see, but the IDs are there. Those are what we call document collections. A document collection on ArangoDB is very similar to a table in SQL, right? Then you've got, for example, an author. So these 2 images happen to share the same author. These 2 images happen to have a set of best guesses. So, each one has their own. It could be somewhat related. It could be completely different, but they have been identified as unique. And lastly, you've got your tag document collections, which is all the little nodes that you see here that are brown, orange-ish. So these are the tags that I showed you in the accordion. You know, when you collapse that accordion and you look at, you know, a specific keyword in respect to a percentage, this is what we're working with here. This is what we call a tag. Okay. So we've looked at 4 collections right now, and these are the 4 collections or the 4 document collections I use: best guess, tag, author, and image. The connections to those documents are what we call edge collections. Okay, so we're going to be visiting that on the next slide. So remember early on, I showed you a picture of, you know, this nice valley in Norway. We're inspecting that image right now. This is image 1015. That's how it's identified in the application. And as a reminder, you've got your best guess document, your author document, and your tag document as blue, purple, orange. Let's start looking at 3 different examples of a data relationship between image 1015 and a tag. Again, everyone good so far? Chris, no questions?
All good, I think.
All good. Okay. So let's start off with our document collection. As a reminder, what you're looking at here, the arrow is in orange, is a tag, and it's got the following data. It's got an ID labeled tag 141. It doesn't matter in this situation here. But what we're interested in is this here. So Google Vision has decided that image 1015 is associated to valley. You know, it found based on the image that it looked at that, okay, valley is a keyword that I can associate with this image, and I want to provide its confidence score now. So how do I do that? Well, I specify the confidence score via the edge collection or the edge, you know, edge document that is connecting the image and the metadata. So now we're on our first edge document, and it's called a tag of. It's the tag of collection, and it goes from tag 141 to image 1015. It is of type label. Ignore that for a moment. I will come back to it later. And it has a score of 78%. In English, what this means is image 1015 is associated to the valley tag. Okay, how sure are you? I am 78% sure. Ignore the type for now. We're going to get to that when we see all the 3 different edge types. Let's go to our next example. We've got a tag number 38, and Google Vision has found that people is a metadata keyword that it wants to associate with this image. So no problem. We provide an edge document for it, and we specify from where it goes to where it ends. We specify the type. Okay, so now we see a second type called object. We're going to come back to that. We specify the score. So again, I am 56% sure that this image contains people. And this is a new attribute that we haven't seen. This is an attribute within your edge document called coord. It's short for coordinates. We're going to come back to that in a second once we visited all the different edge types. Lastly, we're at our last one with an ID of 117. And that name that, you know, we saw earlier that I won't try to pronounce. Again, it's the location, if you remember correctly, it's the location that Google Vision has assigned to image 1015. So we've got our description of the tag of document in this case. It goes from tag 117 to image 1015. It is of type landmark, and it's got a score of 49%, and it's got latitude and longitude attributes. So we've fleshed out all the different tags and all the different tag of types. So now I can start explaining what you're looking at, if you haven't already guessed. On the top left, you've got a label. A label is a simple association of saying, I have a keyword and I have a percentage score, and I want to link an image to that result. It's simple as that. It doesn't go any more specific. But on the bottom left, you start seeing something different. You start seeing, first of all, a type that I've decided to call object, and a set of coordinates that serve as a way of better describing this data relationship. So I'm gonna backspace for a second just to see if I can exit out. Do you remember I said that object localization was something we used in Google Vision? So I said how, you know, based on an image, I can detect not only if there's a bicycle in this image, but where this bicycle is. So this is what we're taking advantage of here. We're saying, okay, why throw these coordinates away? I want to know the exact polygon, the shape that surrounds this object, so that later on I can refine my searches. So back to here, this is why we have a set of coordinates. It's just saying, Google Vision has found people, but I'm going to tell you where specifically I found them at. Is it on the bottom left of the image, the top right, the middle? This is what I'm saying here. The last type that we saw is of type landmark, and this is the more obvious one. Remember when I gave you guys two different demos of the Google Vision? One came back with the Norway landmark, and the other came back with the New York City landmark. Well, this is exactly it. So I am able to say, in certain cases, in certain images, if Google Vision is able to detect that this image, hey, I recognize this place. This is, the Eiffel Tower. Let me give you longitude and latitude coordinates with them. So now suddenly we have a different relationship with this tag. It's more than a label. It's more than an object. It's now become a landmark to this specific image, right? So these three edge document types become very useful when we work on the discovery or the discovery functionality that I haven't demoed yet on purpose, because I want to show it at the end. So we've passed, what we've just passed is the architecture or the database structure demo by explaining, the set of what are the collections that we're using, and what does an image look like specifically structure-wise. So we're going to pass right now very quickly. This is like one of the lighter things to go over. This is just the web application tech stack, if you're interested. It's a derivation off of the MERN stack, MongoDB Express React Node. Instead of Mongo, we're using Arango, very proudly so. And for the client, we're using, again, React TSX, along with the Material UI module for just UI design. It's bilingualized via internationalization, and we're using Viz.js for our visualization functionality. Viz.js is just a library for graph rendering. The client communicates with the server via REST API calls, which is a Node.js application written in TypeScript, wrapped in Express. We've got integration and unit tests written in Jest and using Jest and Supertest. All of this is deployed via Heroku, and CI/CD integration is provided by Travis CI. So this is the application overall. We connect to an instance of ArangoDB Oasis via the Arango.js driver. And this is where we take advantage of things like Arango Search and graph-based DBs. We also use a few external APIs. So on the bottom right, you use Lorem Pixum to fetch your image data set, and Google Vision to create your metadata for each image. And DataMuse is a word finding engine for metadata. I'll leave this to the end if we have time or if anyone's interested. It's on a want to know basis, but it doesn't have a happy ending, so we're going to skip it for now. Okay. We're at the ArangoDB logic side. Right now, what we've went through is, the context of the application. Why did I build it? What is it? How do I structure my data? A bit more detail into how I structure my data. So what does what does a graph look like? What does a graph database look like in ArangoDB for my case? What are the different types of data relationships that you can have towards a tag? The first being label, the second being object, the third being landmark. We've also looked at the tech stack. And now we end up here and we're ready to talk about or get into the details as to, what is ArangoDB doing here to play its part? And I would argue that ArangoDB here is helping me out in two ways. One is through a graph model database. So subsequently, you can access graph traversals. So that's point number two that we'll talk about very briefly. And the second functionality I'm taking advantage of is Arango Search. For those that don't know, Arango Search is a full text search engine integrated within ArangoDB. So that unlocks for a lot of possibilities here. If ArangoDB was able to build its own search engine, then it means that I can combine this with graph traversals to make searching even faster. And so just like with any search engine, you query for documents approved by via a Boolean model. So, if you search for documents that match, a specific Boolean condition, and then you can sort them by relevance via ranking functions. So what you see here is basically a way of organizing your results after you've searched them based on the actual user input. And we do this by establishing documents and queries through the vector space model. It's just a way of representing text documents or data as vectors of identifiers. We're going to be talking about that in a second, but just know that Arango Search is a full text search engine for information retrieval, and it's all within ArangoDB, and all of it is accessible via the Arango query language. So what are analyzers then? Well, analyzers are a way of transforming data for text processing and searching. So analyzers, you can think of it as just as a intermediate step towards achieving, proper search results. So this includes, word tokenization, stemming, converting cases, or removing accents. So for example, if I searched for laptop on a desk, you can use these analyzers to manipulate your input, still have it keep the same meaning, but just be able to expand the amount of text documents that can try to match the query. So analyzers are one of the components. Now we'll pass on to view collections. A view collection, I'll state the definition, it's just simply a way of referencing data stored in different collections via inverted indexing. The best analogy I can give, and I would argue that it's not even a good one, but I'll still provide it, is if you had a phone book that wasn't sorted alphabetically, right? If you were looking for Mark, you wouldn't be able to just split the book in the middle and look for M. You would have to go through every single page, every single row, and check if Mark is there, or Mark Smith, or whatever his last name is. Views allow you to organize your data specifically for quick access. Now, it takes time, obviously, in the beginning to organize this data or sort this data in a specific way. But later on, when it comes to information retrieval, it is extremely fast, extremely fast. So we use view collections to store all the authors and all the best guesses and all the tags that we associate to images, so that when it comes the time to search for them, the view collection has already indexed them via inverted indexes and can access them very quickly. Lastly, we're looking at ranking functions. So we've obtained our results. Now it's time to rank them based on the respective query. We do so by treating documents and the query itself as a vector. So once we have that, you've got two vectors pointing in different directions. You can evaluate the cosine of the angle in between them, and the documents with the smallest cosine scores represent the closest matches. So let's say you've got a query, which is right here, your orange vector right here that stands for Q, and then you've got document 1, which is a vector, and document 2. When I say document, I'm just making this, it's arbitrary. The data is arbitrary here. It could be a tag, it could be like mountain, it could be sky, it could be an author like Gene Smith, or it could be a best guess like laptop on a desk, right? The data here does not matter. What we're interested in is in the angle in between them, because that depicts how close the query is, or how close the document is to the query. This is how we rank our search results after we've retrieved them via the inverted indexing that view collections provide. So all this to say is you've got 20,000 tags that you're working with, and you want to search for all the tags that contain the word mountain or have something similar to mountain. To go through every single one would just be redundant. It would take way too much time. So view collections provide inverted indexing to say, I can assure you that these specific documents already have the mountain tag mentioned, so you might as well look at those, and then you can sort them via the ranking function to display the ones closest to your query. I didn't go into details as to what the ranking function is doing, but just to give you an idea, ranking functions take into account the text length of the document and the amount of times that your match has appeared. So let's say you have a sentence that says a mountain close to another mountain sits in front of a mountain, right? You've got a sentence and you've got 3 matches of mountain versus another sentence where it just says Kilimanjaro mountain, right? You can argue that the first sentence that I provided is a bit more important than the second sentence, simply due to the fact that the ratio of matches to the text length is a bit higher than the mountain one. But maybe I've confused myself. Maybe it's the other way around. If you've got 2 words, Kilimanjaro and mountain, what's the ratio of mountain to that sentence? Well, it's 50%. You've got half versus a full sentence with only 3 mentions. Anyways, if I'm boring you, just ignore all of this. Just know that ranking functions are able to rank your search results based on your input. Okay. How are we doing on time? We're doing okay. So we passed Arango Search. Very quickly, graph traversals are straightforward, right? So if I have a vertex and it's connected to another vertex via an edge, I want to be able to get to that second vertex, and I can do this via AQL. So very simply, this is like a very basic demo of an AQL query for a graph traversal. I first specify the collection that I want to be working with or that I want to be traversing, and I iterate through my images. This is what I'm showing you here. This is AQL, right? So for I in image, which is just a way of saying iterate through all your images, I'm going to limit for the first result. It's a bit redundant here, but we're just testing things out. And then I'm going to traverse. So I'm going to say for every vertex and for every edge that belong to a 1-step distance of the image I want you to return the edge. So what does this mean? Well, you've got the image right here that I'll zoom in. What does a 1-step distance mean? Well, you can argue that this image right here and this tag right here are separated by how many edges? Just 1. So this is why we call it a 1-step graph traversal, or how I like to call it. It makes sense to me. If I want to jump from an image to a tag and there's only 1 edge separating them, well, this is a 1-step graph traversal. So what this query does is we're specifically traversing all the vertices and all the edges that belong to the image I, but only on the first step, on the first level, and then we return the edge. So what I'll do is I will copy paste this, and I'll actually go over to the web console of ArangoDB. This is ArangoDB. This is the ArangoDB Community Edition, and what we'll do is we'll run a query like this. So copy paste, and there, and we can organize it a bit nice so it's easier to read. Okay, everything looks good. Make sure nothing is wrong. Right, so what we've just done is we've traversed through image 0, which is the first image, and we've displayed all their metadata. So they could be tags, they could also be best guesses, or it could be an author, right? Most of them are tags, obviously. There's about 50 tags and only about 1 author or 1 best guess. But what we've done here is just a simple example of what a graph traversal can do. So with these 2 functionalities in mind, with graph traversals and Arango Search in mind, I'm able to build a search query that has an average time of under 20 milliseconds or whatever the amount is that I last remember. So we'll go over again quickly. The search query uses graph traversals, and it uses Arango Search. It uses a view collection. It uses some analyzers. It uses, in fact, 2 different analyzers, one for close matching and one for exact matching. What do I mean by that? Well, the text and stop words is a text analyzer based off of the English language to separate certain keywords into multiple keywords. So if you have computer on a desk, the text analyzer would strip out the on and a propositions and would only return the most valuable words that you could use for searching. The norm accent lower analyzer is a normalization analyzer. That's what it's called, I believe. And what we do here is we remove all accents and all uppercase characters, and we transform them to unaccented and unlower or uncapitalized characters. So we use the first for close matching and the second for exact matching, and I'll clarify what both mean later on. We also use a ranking function, which is the Okapi best matching 25 algorithm to rank our search results. Now, these are just extra buzzwords here. We use double weighted text term frequency, full text length normalization. It has to do a bit with how important and how long your sentence is, how often the word shows up. We can come back to that later. It's not important right now. Doing good on time. So we've got the pseudocode for the search query. Now, what I propose instead is I show you a visual example of this pseudocode, and then we actually try the query out in the web console. I feel that if I were to present this pseudocode, it's just a bit too much text to work with, so I'd rather show it to you visually. So if I can try, I've got like a little trackpad that I will try to draw on, and if this doesn't work, I'll go back to the pseudocode. Okay, so far no questions, Chris?
So far, so good.
Cool. So let's say I have a graph database or graph model instance with about 5 nodes, right? 490, 491, 221, 473, and 222. These are the only images that exist in my database, and their relationships are some of it being shared, right? So what I'm going to do is I am going to start drawing to give you an example of how the searching would work. So I will do this, bring this down a bit. There we go. And select the drawing tool with, yeah, black is good. Let me just double check. Yeah, okay, so we're good. So let's say I am searching for the word apple. Apple. Okay, and all of these images here have a bunch of tags, they have a bunch of best guesses, and they have authors, they have one author. What do I do? Well, the first step is to use Arango Search to pinpoint the exact labels that I find important according to my search query, right? So I do exactly that. I use Arango Search. I use the view collection for fast indexing. I use the analyzer to modify my original search query to expand my possibility of results. And I use the ranking function. So let's say in this case, again, the example here is arbitrary. Let's say for this case that we match this node and this vertex and I don't know, this vertex, right? So we've got 3 different vertices here, and they're all tags, and they've matched for the keyword apple. And you know what, just for the sake of it, let's say this best guess right here also matched for the word tag or for the word apple. So we've got 4 tags or 3 tags and 1 best guess that somehow whose match is related to apple. Now it's time to sort them. So in the BM25 ranking function and in the search analyzer search query, we actually are allowed to specify or to boost specific matches and prefer a specific match over another. What I mean by this is, I would argue that the value of a best guess is more important than the value of a tag. How so? Well, you have about 50 tags and only 1 best guess. And best guess, most of the time, Google Vision does a good job with. So if you were to find apple in the best guess, you sure damn hopes that, this is the image that you want to return. So we sort our metadata or our tags like this. We say, okay, well, this is number 1. Then we're going to say this is number 2, this is number 3, and this is number 4. So in order of importance, in order of value to the current search input, this is how we've ordered it. And now all that's left to do is traverse the graph and count the number of times that we've reached a specific image. So for example, I start with the best guess 1. Let me track that edge. Oh, okay. So we've hit image 473. So I'm going to chalk image 473 down as once. Let's go at metadata number 2. Let's track it. Oh, I see that again, it showed up. So we'll chalk it down again. Let's go over here. Let's track this guy. So we've hit image 490. So let's chalk that down. Now we go chalk 221, etc., etc. We do this for the third vertex. Let's try again. Let's track. Oh, we've hit 473. So let me label this. And then, eventually you'll get a specific number of times that an image has popped up based on your 4 tags or your 4 metadata keywords that you found. For those who know a bit about AQL, this is done through the collect keyword with count into num. So we're right here. We're just counting the number of occurrences, that of a specific image. So all this to say, let's say you come back here with 3. This comes back with 2. This comes back with 1, and this comes back with 1. Well, I would argue that you would want to show image 473 versus 222 because it's been connected to your metadata more than other images. So this is exactly what we do. So let's try that out right now. So if we go into our queries and we open up your close matches query, which is the one that we or part of the one that we use, and we search, for example, for mountain, and we return, we're actually going to return as well the image along with the count. So remove all results, check if everything looks good. All right. So we've returned the top 5 images that have the word mountain associated to them. So we can see that image number 1 being 1023 is the most, so as far as we know, the one that is mostly connected to mountains. And let's take a look at what that is. And so you've got mountains up here, but you've also got mountain biking, which I'm sure Google has associated to this photo. And once you associate a best guess to an image, you overpower a lot of other things, right? Because your best guess here is trying to give you the best idea of what this image is representing. Let's try another one. If I open this guy up and search for that, then I get some pictures of some mountains above the clouds, and you can go on and on. So what we're doing here, I'm going to cut the query in half, and I'm actually going to return the documents or the vertices that I circled in our example. So what I'm about to return is this stuff right here, your tags that I've circled. If we search that, we get an idea of what sort of data are we looking at. So it matched for best wallpaper HD in Mountains Road. That's a best guess. We've also matched for these best guesses. Now, if you scroll down a bit more, you can get to tags. So for example, ski mountaineering, silent mountain, mountain trail. So for each and every one of these documents, I'm performing a graph traversal, and then I'm counting the number of times the total amount of images show up in respect to all these graph traversals that we've done. This is one half of the search query. And if you're interested in knowing the other half, we match. We also have a match by exact matches. So we do not modify the original search input in a way that tokenizes it or stems it. We just remove the accents, and we simply just remove any uppercase or lowercase words. And then suddenly, if I remember the best guess, what was it? I think it was called MacBook Coffee. You have an image number 2, and if you open that up, you can see that this is the image that came back. And if we look for our specific image in our application, we can see that the best guess is in fact MacBook Coffee. So there are 2 ways that we're searching here. We're searching by exact matches via one type of analyzer, and we're searching by close matches via another type of analyzer. This is my entire search function. Then you also have your discovery function, which I did not talk about in the beginning. This is just a way of simply recommending images based on the ones you've already clicked. So let's say we've been given a parameter, it's a list of images. A common discovery would be to iterate through each non-clicked images, sort them by the ranking score or the confidence score, iterate through the vertices that you've of the non-clicked images. So now you've landed on new images, and you collect all images and count their occurrences and pick the images with the highest occurrent count. So what this means is, if I may quickly jump over to this and just say, for example, that all of these images here are associated to the tags that you see around them, right? So for example, this is all connected, this is all connected, same here, and then same here, right? If I'm interested, if I clicked on image 1002, if I clicked on image 1002, and I want to start counting, and if I want to recommend another image to a user based on what you've clicked on, well, I'm going to count the number of tags that another image has in common with the image I clicked on. So let's say that image 967 only shares these set of tags with image 1002, but image 1002 shares these set of tags with image 1032. So I would argue that recommending this or image 1032 is a better approach to your discovery, since you've got how many tags in here versus how many tags in here. Maybe I counted wrong, maybe it's the other way around, but this is using basic graph traversal to count the number of images that we've ended up on based on the common metadata that you have. This is what we call a common discovery. We also have an intersect discovery that is currently a work in progress. And this is how we utilize object localization. So your coordinates that I've mentioned before, to basically match for images that have the same object located at the same spot of the image. And I'll show you an example of that. We also do landmark discovery. So, how can you recommend images based on landmark detection? So if I have the Statue of Liberty and a picture of New York City, I know for a fact they're both in New York, but they don't share much. They don't have the same buildings or labels, but they do have the same landmark. So I can recommend a user, hey, you've seen the Statue of Liberty. Would you like to see a picture of New York or Central Park or stuff like that? So I'm gonna go ahead and try that out for you. So let's say I've clicked on, this is the query. Now I'm showing you for the common discovery. So what I do is I iterate through all my images. I filter for the ones that I've clicked on, and then I traverse my graphs in a two-step graph traversal, and I sort by the highest edge confidence. So if I've clicked on, for example, image 0, and for those who want to know what that is, it is just a picture of a laptop, then I can return with some results here that if I open it up, give you another picture of a similar picture based on the commonality of the tags in between this picture and this picture, right? And what you see here is in fact the query. It was a way of visualizing that query, right? So look at how many metadata or documents they share. The last thing I will say, the quick intersect matches that I wanted to talk about is how do we recommend to users images based on object localization. So if I have a picture, I know I'm running out of time, just bear with me. If I have a picture of a bike, right, and it's sitting on the right side of my screen, and I want to run this query is going to calculate the intersection of the two polygons that Google Vision has returned. And it says, for example, so if I execute this, it'll say, okay, your image 1 with an ID of 76 has found image 859 solely based on the fact that they have the bicycle tag for the exact or similar positioning, right? So basically the polygons of image 76 intersect with the polygon of image 859. And so I can recommend you that without looking at any other tag or not doing any common discovery whatsoever, just based on looking at this white bike and the positioning of it, I can recommend to you that, it is in fact related to this green bike. So this is another way of performing discovery queries. And I will end with, what I'll do is I will, the last query I will show you is the nearby matches. Now I won't run it because it takes I think about 60 seconds to run. It's a bit more complicated and it needs to be optimized, but I might run it and come back to it. But basically what this does is it looks for, oh, never mind, it was super quick. So if I've clicked on this picture of the Statue of Liberty, and the source landmark is Statue of Liberty, and the destination landmark is Statue of Liberty. So I would argue that, this image, without looking at any of its labels or any of its authors, I can recommend that these are, did I click on the wrong one? Yeah, I did, my bad. These are in fact similar. So what I'll do is show you another picture of, let's say you've got, so you've got ID 859, and then you can open that up. So these are in fact two different pictures. We have found that both of these images are located at the same place and their distance is actually quite close. And without looking at any other tags or Statue of Liberty metadata, we can say that based on the latitude and longitude similarities, we can recommend you this picture. So again, these are all a work in progress, just 3 different ways that you can recommend pictures to another user. The last thing I was going to show you is onboarding, but I mean, it's pretty straightforward. If you're interested in forking this repository and trying things out, it takes less than 3 minutes to get up with, all the metadata and all the images and all the authors and best guesses that you can see in production. It's just with a quick restore script, and that's about it. I apologize for ending a bit late, or 60 seconds late. Now, I will be sticking around for Q&A in the event that somebody does have questions. But again, just to wrap up, computer science student at the University of Ottawa, internship experience in DevOps and microservice development. Love to work on side projects like this. And seeing this online setting has allowed me to start applying for, US-based or Europe-based internships. So feel free to get in touch. My contact is available right here, or you can look at me. You can look me up on GitHub or LinkedIn. That's about it.
Awesome. Alrighty, thank you, Anthony. Oh, and we'll send around all the links that Anthony mentioned as well with the video. Once we'll send around the recording to the email, and once we get it uploaded as well, you can find the links there. But then, yeah, of course, if you have any questions, definitely reach out to Anthony. And also, if you do have any interest in doing the Community Pioneer Meetup, as I mentioned in the beginning, we are always happy to have community members showing off their projects, just like Anthony. So if you want to do a webinar like this, write a blog post, tutorial, or just in general, just share your use case with me, I'm always happy to hear about them. But yeah, definitely thank you again, Anthony. I think it's a pretty cool project. And I like that sort of at the end, you can start seeing how this project can continue evolving as well with this idea of using the location-based stuff and having even just being able to work with the geo coordinates for the images. I think that's pretty neat as well.
Thank you. It's a pleasure. And I will stick around in the event that somebody asks questions. But again, thank you so much for organizing this.
Yeah, definitely. And actually, Jörg is giving praise. Really awesome. Thank you for sharing. Awesome. Okay. Well, yeah, we'll hang out for a few more minutes here, but otherwise, everyone, thank you for joining. And hope you all have a great rest of your day.